Hi guys. So the way we talked about the other day was how to do research using Xilinx tools. And as I mentioned, there's a difference between Xilinx tools that are on the server versus the ones that you can install for testing on your own laptop. And the main difference is that the Xilinx tools that are installed on server have an academic license, which means you can run up to 25 experiments at a time. So now, so you have to log into one of the servers. Don't use the Linux one because that is your interface. That's for your interface. That's for school's interface. So IT is not gonna like it. Use homework. And here, the first thing that you do is to go to clone the Git that I sent you, which creates this hls crypto directory. So here you see 3 encryption workloads. Each one of them have different implementation. So if we go to AES, naive, now each folder has 3 files, the AES.h, which defines the interface to the module, the .cpp file, which is the file that will create your hardware module, and then the test file, which is needed for HLS tools to test your module. So the first thing you do here is to copy the TCL script that I sent you. Each simulator, each EDA simulator really has its own commands, and these commands usually can be scripted in a file that is the .tcl. So that's the scripting language for EDA tools. So after you copy your hls.tcl, this is the file that I sent you. After you copy this one, you need to edit it for this project. So first thing you do is to use a name here. So what you want to have information about the workload and the type of implementation. So I'm going to use the path to it. And edit the name. Let's say that. Then I want to change the name of the file. So aes.cpp, here is aes.cpp as well. This is, now the test is going to be AES_test. So that has changed. So if we were in another directory, these two needed to change. Then you want to look for the name of the main function, which is the top function in the aes.cpp. In HLS, you do not have a main function. You have the top function. So my understanding of this set of workload is that the first function in each file is the top function. So here you want to use AES encrypt. Change the top function to this. I'm going to show you for another project how it would change. So now you have everything. You save this. And what you want to do is to run the HLS tickle, just so. So it add the design, it add the test bench. Now it's creating the solution for it. It sets up clock as default, which we told it to use 10 nanoseconds period for it. Generating RTL for this module, instrumenting the C test bench. So this is one of the reasons your previous codes that you showed me was failing, because that test bench was not designed for HLS tools. The error you see here is not very important. It's for Questa Sim that you're not really using. And the reason I'm getting it is because I'm on a server different than the servers that you're gonna be on. So now if we go to this folder that's just got created, we go to solution, we go to synthesis, we go to report. Here we have, if you want to process this data, use the XML file. So write a parser for XML. But to show you how the data looks like, I'm going to use the report, which is a text format. So here's all the information you need. It has the version of the tool that you use, the name of the project, what type of board it's using, what's the latency for it is. It has even the instances in your, if you have time, I don't think, first write the report, but if you have time, you can play with this information. These are the instances of the functions. And then if you go down here, you will have the utilization estimates. Flip-flop, lot are the only things that are used for this workload and how it's implemented. You have the total, you have the available, which is how much of these resources are available on your board, and you have the utilization. These workloads are very small, so the utilization for the board, so the utilization is always going to be small. So I would highly recommend you guys use the total values. And that's it. That's all you need here. If we were in another implementation, let's say present, and here we have the mask and naive. When I wanted to edit the HLS, here, as you see, the files are a little bit different. So this is the name of the project I use. Now the add file, again, the file that is going to create your hardware module. So it's going to be the present.cpp here. The test bench is going to be the file that has the underlying test.cpp in it. That's what you're going to use for the TB, see, test bench. That's going to what you put. And then to get the top function, you open the present.cpp, the first function. The first function is of type of this. So the value it returns is of this type. And these are the two arrays that are its input. Don't forget to include in your report what these workloads are going to do and how the algorithm works. It is essential to add these things in your report. And that's about it. It's gonna take less than an hour to have the data for your CSV, for your machine learning algorithm. Good luck.